All right, folks, so let's take a look today on a simple strategy to factor simple trinomials. We'll call this the MAN method, the M-A-N method. But before we jump into factoring simple trinomials, first we're going to take a look at really what that is. So factoring is the opposite of the distributive property. So factoring is breaking something down, breaking an expression down into factors, rather than having it in a sort of standard form. So if I can take a look here at two factors, I'll start off with two factors, and that's x plus 5 and x plus 7. We'll start off with these. We're going to expand them, and this is often referred to as the FOIL method, in which case we're taking a look at the first two terms, so the first term of each factor, and then we're going to look at the outside two terms, and rather let's fix our coloring here. The outside two terms, and that would be the x and the 7, and then the I stands for the inside two terms, nice and straightforward. Inside two terms, that would be the 5 and the x, and lastly we look at the last two terms. That would be the 5 and the 7. So you'll notice that that each term of each factor is used twice, and that makes sense because each term is going to be multiplied by each term in the other pair of brackets. So we're going to take a look here. We're going to expand it. That means that's x times x would be our first term. That's x squared. Our second term would be, again, the outside. So that's x times 7. Gives me 7x. And then the inside terms, which would be 5 times x. And lastly, let's give ourselves some more space there. And lastly, we're going to multiply the final term. So that's 5 times 7. That equals 35. Now from here, we would collect our like terms. There are only two terms that are alike here. That's the 5x and the 7x. So our x squared would remain the same, and then 7x's plus 5x's would equal 12x's plus 35. So this, if we work in this direction, this is called expanding. Expanding. Again, this is the opposite of factoring, and we use this, when we're doing this, we call that the distributive property, because we're distributing the first factor into the second factor, if you will. So we have expanded this. Now we need to take a look at this. We need to consider it and see how we can use these kinds of strategies, or how we can use this information that we've just found in order to work in the other direction. If we begin with something that looks like this, how could I get up to that final factored form? Well, I can take a look here, and what I really want to examine are my coefficients. So there's no coefficient in front of my first term. There's no number in front of the variable. And my second term here has a coefficient of 12. And really, we should call the coefficients a in front of the first term, b in front of the second term, and so b equals 12, and c in front of the third term, and that the third term has no variable, so it's entirely coefficient, so our c equals 35. So I need to figure out how to get a 12 and a 35, how I managed to get those from beginning with a 5 and a 7. Now, if I lay it out like this, hopefully it's relatively easy to see. I get this 12. This 12 is 5 plus 7. Nice and easy. Whereas the 35 is 5 times 7. Okay, so if I start off with 5 and 7, then I end up with 12 and 35 in those spots. So now I need to perform this in a backwards fashion. So if I begin with a number, say 35, if I use that to find two numbers that multiply to 35 and two numbers that add together to get 12, if I can find the same two numbers, then I should be able to factor something like this. So we're going to expand this in the same way we did before. So that's the first two terms, then the outside terms, and then the inside terms, and the last terms. So if we start off like this, then we should have, that's x squared plus the outside term, so plus dx plus bx as the inside terms plus b times d. Now if I can take this, again, we're using, rather than using numbers, we're using letters to represent those numbers, so we know that this can be used in a more general sense. If I try it here, then I end up with x squared, and I'm collecting my like terms again. I notice that these two terms are alike, so that's plus b plus d x. And that comes from having dx's and bx's together. That's d plus bx's plus b times d. Okay, and we notice that same pattern that we found before. This here is our two opposite roots, if you will, being added together. So those internal numbers, the 7 and the 5 that we had in the previous example, that's b plus d added together. And lastly, it's b times d multiplied together. So that seems to work. So let's try it out. We'll put it to the test down here. We'll try it out right here. So I see that I want some numbers that will multiply to 6 and some numbers that will add to 5. And we need to figure out what those two numbers are. So that's why it's called the man method down here. So we'll multiply to 6. Well, what are the factors of 6? 1 and 6 are, and 2 and 3. And I can't forget my negative factors, so I can just repeat these same ones, but the negative version. So -1, -6, -2, and -3. Okay, so now I can add up all of these pairs of factors and see if there's any pair that adds to what I need. Well, 1 plus 6 equals 7. 2 plus 3 equals 5. I don't need to go any further here because I've just found a pair of factors that add up to 5 like what I need. So my two numbers here are 2 and 3. And we're going to use those two numbers to factor this simple trinomial. That will bring us to x plus 2 and x plus 3. So this is a simple way of doing it. It's a nice way to break it down. Now, things to consider here. This factoring method, it only works for what are called simple trinomials. And a simple trinomial is a trinomial that has no coefficient, or rather a coefficient of 1 in front of this first term here. So it will not work if there's anything other than a 1 here. You need to do a more complicated strategy if it's what's called a complex trinomial, and that would be what that would be called. So this can be used to factor these. Now, if you're unable to come up with any numbers, and sometimes that will happen, if you're unable to come up with any numbers that satisfy this, then what you would have to be trying is your quadratic formula. But we're not going to do that today. That would just be where you would need to go if you couldn't solve it using this method.